Welcome to Engineering Visualization channel. So today we are going to solve the Vtu-Caed model question paper. Okay, so here you can see the model question paper 1. In this I'm going to solve projection of point problem. Okay, this is a solid edge 2024 student version. Okay, first I'm going to draw an XY line. Okay, so we can make use of this video so that many of the students have been asked for the doing the solving the model question paper of the CAD. Okay, for them I'm doing this. So guys, please make use of it. Okay, subscribe to my channel and share to your classmates and friends so that they can be benefited. Okay, so here with respect to the question here, so in the question what they mentioned here, so it is resting on the HP plane, say resting on the XY line. So you can see the question, a point A is on HP means it is nothing but the front view. That's why I have put a point and mention A dash. Okay, and now the length we should consider. So here the point, it is the top view lying in the first and fourth quadrant. In both first and fourth quadrant it is lying below the XY line. So that's why I'm drawing the length of 30 mm, so below the XY line. Okay, you can just see first and fourth quadrant, so it is below the XY line. That's why I'm putting it and mentioning it as A. Okay, now after that see the question, you can change the thickness here. Okay, this is the new version of the software, that's why I'm getting a little bit of time because the commands were of different type. Okay, so if you want this software I can share this. Okay, this is the, for top A it is 35 mm drawn, and then if it is a another point B is on VP. On VP means it is nothing but the on VP means it is nothing but the top view, and below HP. So below HP means we don't know how much distance it is. Okay, what they mention here, it is the line joining the front views makes an angle 30 degree to XY, while the line joining the top views makes an angle 45 degree with XY. So that means we should connect with the top views with an angle of 45 degree, front views with an angle of 30 degree. Okay, that's what given in this problem. Using this sentence we have to draw. So what I'll do is, here I'll be connecting the top views at an angle of 45 degrees. Okay, so from the top view I'll be drawing an angle line for a length of 45. So here just by randomly we can draw, and then we can change the angle here. So first I'm drawing one line. Okay, and I can change the angle here, can change the thickness. Okay, so select the line and select its thickness as 0.13. Okay, now here I'll change the angle. Now you can see here I'll go to angle between. So before that I'll be drawing one smaller horizontal line here from at the top A. Okay, so go to angle between and select the angle between these two lines and angle you're getting in. Now we can modify, change it to 45. Yes, now it has been changed. Okay, this is what the top view connecting the angles. Okay, an angle of 45 degree. So you can see the question here. So another point B is on VP. On another point B is on VP means nothing but the top view, and it should be drawn on the XY line. Okay, so we know that the top views are connected by an angle of 45 degree. So from the top view of A already we have drawn an angle line at an angle of 45 degree. Now I'll put the point. So that top view we should be marking on the line passing the 45 degree and on the XY line. Okay, so the intersection of this 45 degree line and on the XY line. Now what I'll do is we'll be drawing another line which is of angle 30 degree. Okay, that is for front views, like this. Yes, downward I'll be drawing it. So just randomly I'll draw it, and then after that I'll change the angle. Just randomly you can draw here. Don't worry about the length. Now we can change the angle. So this angle should be 30 degree. Okay, now you can see the top view on VP means nothing but the top view. It should be drawn on the XY line. Okay, another point is on VP and below HP, and they have not mentioned any distances, right? So we can put the point here, go to point and just change the thickness to 2 mm. Okay, and here I can put yes here. Now vertically downward is another point. Now we need to draw with the vertical line here. Yes, I can change the thickness of this line. So I'll be making it as 0.13 mm. Change it to 0.13 mm here. Okay, you can see here we should mention the points here. Okay, now mention the views here. So here this point is exactly b small b, and this is b dash. You can see the top views are connected by angle 45 degree and front views are connected by angle 30 degree. Now we have to find out this distance. You can see what they mentioned. Find the distance of the point b from hp. Okay, so that distance we need to find out. So we just measure it using smart dimension. So that completes the problem, guys. Subscribe to my channel and like the video and share to your friends and classmates so that they can be benefited. Now we move on to the second problem, that is a line problem. So here what given, the distance between the end projector through the end points of the line AB is 60 mm. The end projector distance given 60 mm. Okay, the end A is 10 mm above HP and 15 mm in front of VP. So here first we need to draw the locus lines for the end point of the lines. For end point distance they've given 10 mm above HP and 15 mm in front of VP. So first what I'll do, I'll be drawing an XY line. Okay, and marking VP because we know that from projection of line onwards we need to use only first quadrant. Okay, so draw XY, write XY, VP, HP and Y. Now we need to draw the locus lines. You can see here 10 mm above HP and 15 mm in front of VP. Okay, so I'll be using here offset command. So selecting XY, so here I can define the distance. I'll type 10 mm here, so it will be above. So give accept. Okay, the same way I'll be drawing 15 mm below. Guys, anyone want this software, that is student version, I can share the link. Okay, how to download also I can make a video. So now you can see end B is 35 mm in front of VP. So the another end point of the line distance and they have given. Okay, so step by step I'm going to do it, so closely you can follow and try to understand. Okay, so in this problem they have given only here the line AB appears 70 mm means it is nothing but your apparent length. You need to find out the true length here. Okay, so first I'll be drawing 60 mm line here from this end. Horizontally I'll draw it. Yes, 60 mm. This is the distance between the end projectors. Okay, 60 mm I'll mark. Okay, after that we need to consider another drawing the another locus line, that is at a distance of 35 mm in front of VP. Okay, for and I'll be going to the offset command. So typing 35 from the XY line. Okay, XY line and draw. So it is also done. Now you can see we have done this till here. So now after this already I have drawn here 60 mm projector line, guys. So and here in the question they given the line AB appears 70 mm long in the front view, means it is nothing but the apparent length in the front view, that is A dash B dash distance they were given in the question. Okay, Complete the projections and find the true length of the line and its inclinations with HP and VP. Okay, inclinations we need to find out. So no inclinations given in the question, guys, here. Okay, so you need to be careful in solving this problem. Okay, so at the 60 mm, what I'll do, I'll be drawing one vertical line. Okay, so that we can get the exact end points here. Okay, so this projection of line is totally the concept based subject, guys. So we should not draw line of length there. It is 70 mm this one, but I don't know the angle, so I cannot able to do it there. So because we don't know how much angle it is, right? Cannot able to do it. So you can see there are now vertical line I need to draw. It's totally concept based projection of lines, guys. Here as vertically one line I'll draw, as I mentioned, so that I can get the end point exactly here. Okay, where we have to end it. So at the end we are drawing one vertical line, guys, that is connecting top and front view, A dash, B dash, like that. The same way here also we are drawing it. Okay, so now in the front view I'll be drawing 70 mm line now. Okay, because we don't have any angle, right? So for that we need to do like this. So here to find out the commands little difficult because you're not used to it. Okay, so here can show the distance. So here the distance it is 60 mm. That's what I am showing here. Now again go to line. Here you need to draw a line of length 70 mm, that is upper end line. Now you can easily connect. Okay, yes, this is 70 mm upper end length, so you can mention A dash, B dash. Okay, one length we got it. Now this upper end length we should rotate. So we know that we always have to rotate the upper end lengths. We never rotate the true length of lines. Okay, guys, you can like the video, subscribe to my channel, and if you want to join, you can join for this membership. It is only 19 rupees per month, and it is you can cancel at any time. So take arc by center, measure 70 mm, because we need to rotate this. Okay, rotate it and then project downward. So rotating it and projecting downward, we get the true length now. Okay, just draw a vertical line here. Okay, so this is 70, you can show this is upper end length which is given. We need to find out the true length, right? So I have been projected till the locus of 35. Okay, I can trim it that extra length. Okay, so now join it. For the end points we should connect, right? So from A dash we don't have the exact point. From here I'll be drawing one vertical line downward. Yes, this point is A. Can now join this A and that end point we have joined, right? So join it, that is nothing but the true length. So to show the difference here, I'll be drawing this true length by thick line by 0.50 mm. Okay, so we got the true length. So we know the true length in top view exactly equal to true length in front view. So end points also we got it. So at the end point of B dash, I'll be drawing another locus line here. You know, wherever the end points of the lines exist, we need to draw these locus lines. Okay, I'll be drawing the locus line. So here exactly at this point I'll be drawing the locus line. Okay, so true length we already got it is 84.4. The same length I'll be drawing the another true length. Okay, joining this locus line, type the same length. That is how much it is, 74.44, and enter. And then merge with this where it is exactly cutting this point, right? Just join there and show the dimensions. So it is 74.44, guys. That is true length, same. True length in top view and true length in front view will be same. Okay, now we need to get another upper end length. Upper end lengths will not be equal, guys. Okay, you know this concept, right? If you want to refer, you can refer my playlist of projection of lines. You can understand all the concept. So draw projection line vertically downward, go to arc by center. Now yes, in this command we get it. So select distance from here to here and then cut an arc till here, locus of 35. Yes. Okay, now you can join using line. So now we are getting another upper end length in top view we are getting. So this is AB, so we can mention that. So guys, we can measure all the distances, angle between and all. Okay, now we got it, both upper end lengths and upper end angles, true lengths and true angles, everything we're getting it. So just to zoom it little bit. Okay, sometimes you cannot able to get the exact line. So 29 degree, 31 degree, so we need to measure the angles, right? Guys, thank you all, thank you for watching my video. So subscribe to my channel and share to your friends and classmates who can be benefited, and you can join this my channel at a very less price of 119 rupees, and you can cancel at any time. Guys, thank you all, thank you for watching my video. So I'll be sharing another next videos of this model question paper 1, so you can get this solution definitely very soon. I'll be working on it. Thank you for your support. Thank you all. Thank you for watching video. Welcome to engineering visualization channel. So today we are going to solve the second problem, that is projection of solid in model question paper 1 Vtu-Caed. So the question here, it is hexagonal prism, 25 mm side of base and axis height 60 mm. So first I'm going to construct the top and front view of it. So it is resting with one of its edges. Okay, so the starting here we need to construct an XY line and writing VPHP, writing the first quadrant. So watch the full video, you can able to understand all the problems related to this model question paper. So subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Write XY, write VPHP. So to construct a hexagon, go to polygon by center command, take sides 6 and place the hexagon with respect to edge. Go to smart dimension, select any one of the sides and click on it. It will show dimension. Now you edit, type 25, enter. Okay, it will change the dimension. Since it is a new software, that is Solid Edge 2024, so I'm not used to this new software. Initially it will take some time. Okay, write the notations. So top face notations are visible, so that were written as A, B, C, D, E, F. Okay, and bottom face notations are not visible, that are written within brackets. Okay, A1, B1 and C1 like that we write, but it should be written within brackets. So draw two diagonals, that is thin lines, to find out the center of the axis. So here center of the axis we write with O and O1. So O1 will be the bottom face center, so it is written within brackets. So draw the projection lines. So here axis height is 60 mm. So in the front view of the prism, it is a hexagonal face, rectangular face it is. So give the height 60. Yesterday I got to know the summary of my channel that around 11,000 students have been visited last week. Only 150 students have subscribed. So I want to appeal to the students that make use of this channel so that you can score well in the exam. Subscribe and hit on the bell icon so that you can get the latest notifications about the related videos about this channel. Okay, so write down the front view notations which are all visible, that are written within brackets. Those which are not visible, written within brackets. So select the entire thing, use the move command. Okay, creates a copy and drag it along the xy line. Now we need to rotate. So here inclination to HP, how much they given? 45 degree. So we have to incline with respect to base edge inclination. So go to rotate and here rotate at an angle of 45. So here the important thing here, you need to unselect the copy command because it will create the multiple copies of it. So go to rotate and select the base edge, give the angle 45 degree. Extend the axis using extend to next command. So check the angle. So angle here we're getting it is 45 degree. Now use the line and draw the projection lines downward to complete the second position top view. Okay, if any student want this particular software, that is student version Solid Edge 2024, you can comment me in the video so that I can create a link and I'll share the link in my video description. So write the notation for the top view. So top view, in the top view bottom face it is A1 B1 C1, like that you can write down. Draw a projection line from the O also. This is O1. Same way for the top face, you can write down ABCD. So to construct the second position top view, we know it is having three steps. First step is constructing an outer boundary line. So join all the outer points. Now write the visible face. The top face is visible. That means top face hexagon, it is visible from the top view. Okay. This rectangular face also visible. A1 and BB1 is visible. So bottom face of the hexagon prism not visible. So it should be written with the dashed line. Part of the hexagon, base of the hexagon here. So I will be selecting the dashed line. Finally, there is an axis you can connect. Okay. Now in this problem, you just see they have given angle of inclination to axis for both HP and VP plane. We know the concept for beta angle. If the angle of inclination, if it is given with respect to axis for both HP and VP, means it is beta angle. Correct? So see the question paper. Angle of inclination to VP, it is 30° with respect to axis for the VP plane. So angle and I'm drawing here. So here the first arc length we should be drawing at 60 mm. Okay, need to find out the beta angle, right? So front view, first position front view, it is 60 mm. So draw an arc for a length of 60 mm. By taking one reference point, you can give this as O01. Now where we have cutted the arc, right? So there we need to draw an locus line, horizontal locus line. Now second position axis length we should consider. Okay, it is 42.43. So again go to arc by center. Just move the cursor on the first arc. You'll get the reference point. Now type 42.43 and cut the arc. Guys, here I'm making videos related to solid software. Why? Because 80% of the marks it is there with respect to doing in the system, that is using software. That's why I'm not doing any sketches. I'm doing only in the software. Okay, so make use of the video, because this model question paper solution I'm doing it for for the request of many of the students. So you can share to your friends and classmates in the WhatsApp group so that they also can be benefited from this video. Okay, so now we got beta angle is 45°. So this is O2 and this is O1. Now we need to copy the second position top view. Okay, use the move command, creates a copy of it, and then copy using the axis point O. Now rotate and then place it on the angle line. So draw the projection line upward to complete the final position. So here when you are placing it, you need to be careful. So you need to place it on the exact line. Okay, sometimes mistakes do happen, no need to worry. You can change it and place it accordingly. Now draw the projection lines upward to complete the final position. Like this randomly you can draw, or there is another method by which we can connect exactly with the pinpoints. Okay, draw the projection lines like this also. Just move the cursor over that point and then bring it back, so where you want to exactly end, you can end it like this. Guys, you can subscribe to this channel and share to your friends and classmates in the WhatsApp group. They also get benefited from this. I can write the namings here. First I will start writing from the bottom face, A1, B1, C1, like that. You can see the intersection point and then write. Okay, in the same way we write the notations for the top face also. I think in top face the projection lines we have not drawn properly. We do it again. So in the exam, no need to get panic, guys. You can take your own time, and the main important thing in this subject is you need a little bit of practice. You need to understand the subject properly, and then do little bit of practice, so that will be enough, so that you can easily score. So this is one of the scoring subject in engineering. Okay, so we can write down the notations like this. So here F and E are the nearest points. So if we connected with adjacent edges are the dashed lines. Okay. So now we are making the thick lines here, thick and thin lines. So here the remaining diagram I have written with the thin line. I'll making it as thick. We're selecting and making the thickness as 0.50 mm. Okay. Okay, here now the problem is completed. Thank you guys. Thank you for watching my video. Subscribe to my channel and share to your friends. Now we are moving to the problem number 3 in the model question paper 1 Vtu-Caed. So question number 3 it is the isometric projection. So here given it is nothing but combination of cylinder and rectangular block. Okay. So to construct here, first we need to take one horizontal line as a reference. From this reference point, I'll draw one line, that is line with an angle of 30°. So here I'll take 60 mm. Okay, and angle will take 30°, because in isometric we should use angle 30°. Okay, first I'll be constructing an rectangular block. Okay, so here the rectangle block having base sides 30 mm 30°, and vertical edge 60 mm, angle is 90°. Again length is 30, angle is minus 150, and then vertically downward you join with a length of 60 mm. Okay, now we have to give the width here. So width of 30 mm at an angle of 150°. Okay, so the same line I'm going to transfer it using move command, creates a copy, then place it like this, so it will reduce your effort. Okay, now complete it, so that rectangle block will be over. Okay, now we have to draw the cylinder. So cylinder, it is there exactly at the center of the block. So the total length is 60, means we need to subtract by 15 mm. So just see, so watch the video till the end, you can understand. So vertically downward by 15 mm, I'm coming downward 15 90°, and then 30 mm, then angle of 150. Again here, now the length required for the box, it is 30. Okay, again horizontally. So this is the box we require to construct the ellipse here. So from this corner point to the midpoint. Okay, again from this corner point to midpoint. Okay, from this corner point to midpoint. Okay, from the corner point to the midpoint, you can select the line. So now using for arc by center method, that is using arc by center method. So here we will be constructing an arc here to construct the ellipse, taking this length, draw an arc. Same way from here to here, take this length, draw an arc. Now for the third point, okay, take this as a reference point, taking this line, draw an arc. Okay, and same way here also, take this length and draw an arc. So we have completed an ellipse here. Same way we need to construct another ellipse at a distance of 60 mm. For that, as a reference, I'll be considering a length of 60 mm, and then another box of ellipse I'll construct. Okay, for a reference I'll be taking this length. So length of 60, angle minus 150. Because we should be extruding at a distance of 60 mm, right? That's why I'm considering this length of 60, angle minus 150. Okay, from all the four corners of the box I'll be extending the same length 60 mm, and angle is minus 150. Okay, now here we got the endpoints. Here we need to construct an box here. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So it is important, guys, you should go through all these model question paper. There may be chance you can get the same questions for the exam, because the question paper, it is coming from the VTU. So make sure you go through all the problems, because we don't know which problems may be coming for the exam. Okay, in each model we have 50 different questions. Okay, just go through my videos wherein I have explained the problems with all concept with less time. Okay, guys, make use of the videos, and during the exam time it is very helpful that you can revise this subject using my videos. Okay, because you may be forgetting all the concept, because the practical exam, it is there after 1 month. Okay, so draw a diagonal line. Okay, now join from this end to this end. Again, join from this end to this end. Okay, so now we need to make these lines as thick lines. Okay, so rectangular block also I'll make thick by selecting all the edges. Thank you all. Thank you for watching my video. Subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Thank you all. Now we move on to the next problem, that is development. That is question number 4. So so watch the video till then, you can understand all the problems. So here we need to construct a square pyramid of base heads 40 mm and height 60 mm, resting with its base on HP, with all its base edges equally inclined to VP. So that means we need to construct a square lamina with respect to corner position here. Okay, so square pyramid, it is resting with the corner position. Equally inclined to means it is nothing but corner position. Remember it, guys. So first I'll draw an XY line. Okay, go to rectangle by center. So take thickness 0.50 mm, give width 40 mm, height 40 mm, and angle is 45 degree. Okay, width and height both are same in square. Okay, and give the angle 45 degree. Yes, you got the square lamina with respect to corner position. Measure the dimension. So here height of the square pyramid, it is 60. So give the namings A, B, C, D. So since it is a pyramid, we need to draw the inside lines, that is slant edges should be dark. Okay, inside line should be dark because it is a pyramid and it is having slant edges, right? O1. Okay, so now draw the projection lines upward. So make sure you draw the straight lines by zooming in. Okay, just scroll it, you can zoom the. Now height given 60. So take an axis, give the height 60 mm, construct triangular face now. Just show the dimension. So top and front view of the square pyramid is done. Here they've given a cut plane which is inclined at an angle of 60° to HP, passing from the right corners of the base, right extreme corners of the base. So in the problem, right extreme corner is C dash. From C dash we have to draw an section plane at an angle of 60° to HP. So take section plane from the C dash end and draw an angle line. So just randomly can draw like this, and then you can change the angle. Okay, yes, you can give how much you're getting here. Okay, now change it. So angle, it should be 60°. Okay, now we have drawn an section plane. Now we have to mark the cut points here. Okay, so cut points will be marked with the numericals. So cut point 1, it is cutting on a slant edge AO, and 2, it is cutting on a slant edge BO. Okay, and cut point, it is occurring at the extreme corner 3. Okay, 3 is occurring at C, and then 4, it is cutting at DO, that is slant edge. Okay, so cut points are mentioned, and this is what our slant edge, because the CO slant edge is parallel to XY. No need to find out extra slant edge, it is already available. So draw a straight line for length of this slant edge length. Okay, now go to arc by center and draw an arc by taking this length. So randomly you can draw an arc. Okay, no measurement, just randomly like this you can draw. Now we have to cut this arc into 4 equal parts. It is 40 mm we need to cut. So take arc by center. So from this reference point, cut a length of 40 mm. Again cut an arc for a length of 40 mm. So that's why you give the radius 40. So cut it like this. Again 40 mm you need to cut. Again take reference point properly so that you can doing the problem correctly. Okay, so now join all these cut points with the vertical line. Draw triangular faces. Okay, 4 triangular faces are done. Yeah, now we have to draw an base of it. So just drawing it we can do. So now write the namings here. O, capital A, capital B, capital C, capital D, and capital E. Okay, now these cut points, right, we need to transfer on the slant edge length. Okay, So we have marked the cut points on the, yes, these cut points were the right 1, 2, 4 and 3. You need to transfer on the slant edge. So like this you draw horizontal line till here, and then from here to here. Okay, now right, this is 1, this is 2, 4. Guys, it take a lot of effort to solve these problems. Okay, it is because of the request of the students I'm doing these problems. Okay, so please make use of the videos and subscribe to my channel. Okay, so last week around 11,000 students have visited my channel, but out of the 11,000 only some 150 students have subscribed. So it is not a good thing, guys. So whoever is watching the videos, please make sure you subscribe and hit on the bell icon so that you can get the latest information about this drawing subject. Okay, this is very important because you're in the first semester or the second semester, and this is one of the scoring subject, so that you can make use of it. Okay, and one of the biggest advantage of this channel is that you can revise for the exam for within a less time. Okay, because the here the videos are made according to the student mindset. Here we need to cut the arcs. Okay, arc length for 6.54 on a OA. So on two sides we need to cut this because we have OA on two sides. Yes, this is 6.44 radius. You can type and cut it. And then on OB and OD it is 12.17. Cut 12.17 on OB and OD. On both it is acting on an extreme corner, means directly we can write 3 at the cut point of, so you can mention the naming now. 1 here, also 1. Okay, sorry, that is the 1 only, not 4. This is 2 and this is 4 and this is 1 again, and 3 we are getting here. Okay, so now we need to join this. Now we need to join all the. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Thank you for watching my video. Guys, you can share in the WhatsApp groups. Thank you all. Thank you for watching my video. Welcome to Engineering Visualization channel. So today we are going to solve the model question number 2, Vtu-Caed. So here in the question number 1 given, it is a circular lamina inclined to the VP, appears in the front view as an ellipse of major axis 60 mm and minor axis 40 mm. The major axis is parallel to both the HP and VP. One end of the minor axis is in the both the HP and VP. Draw the projection of the lamina and determine the inclination of the lamina with the HP plane. So in this problem we have to use the dimensions of the ellipse, that is major and minor axis. Okay, circle dimensions they have not given, and it is occurs in the front view. That is, we need to use major axis of the ellipse 660 mm in order to construct the circle. Okay, this is one of the special type of problem. Okay, So in this problem they have not given any kind of inclination. We have to use the data which is given in the problem to solve the problem. Okay, so first we'll be drawing an xy line and writing vphb. Okay, so here the first position will be in circle, but for that circle they have not given any dimensions, but they have mentioned the dimensions for the ellipse, that is major axis 60 mm and minor axis 40 mm. So the major axis of the ellipse will be the same dimension as that of the circle. Okay, so this is, I think, the last problems what we get in the solution book. Okay, so that means you can expect any question in the exam, because this time the question paper it is coming from the Vtu. You can expect any problem. Okay, so better to refer all the types of problem with the solution. Okay, here I'll be constructing an circle using center method. So diameter will take directly the major axis dimension here. Okay, so in the question given the major axis it is 60 mm, that means we'll take the same diameter, that is 60. Enter. Okay, now we need to divide this circle into 4 equal parts. So watch the video till the end so you can understand the concept and how to construct in the SolidEdge software. I think this problem I think I have not done in my YouTube channel. So using extend to next command, you can extend these lines. Now write down the namings and draw the projection lines downward to construct the top view. Write down the notations and then project the lines downward to complete the top view here. Okay, so if you want the solution of all the problems in the drawing subject, so you can subscribe to my channel and hit on the bell icon for the latest notifications you can get, and share to your friends and classmates in the WhatsApp group so that they also can be benefited from this. Draw the projection lines downward to complete the top view. So here I am finding little difficulty in this software because it taking too much time to load. Okay, that's why I'm, otherwise I could have done this problem within 10 minutes. As I'm clicking and dragging out, it is taking more time, I don't know. Okay, so first position we have done. Now we'll write the namings of the top view. Last week around 11,000 people have been watched my channel, but out of 11,000 only 150 students have subscribed. So I request the students who are watching my channel, so please subscribe, okay, so that it will be beneficial for me also, okay. Okay, now in the second position we have to draw the ellipse here because we don't have any kind of inclinations in the problem, okay. So here the major axis dimensions, it is 60 and minor it is 40. We have to use these major and minor axis to construct the ellipse here in the second position. Then after that we will find out the angle, okay. So for that what I'll do, I'll be just projecting this major axis dimensions horizontally. Okay, this is also the 60 mm only, the major axis. Then from the middle I'll consider the minor axis distance 40 mm, that is I'll be drawing on the either side by 20 mm. You can see in the question. So minor axis 40 means 20 mm we have to draw on either sides. Now draw the ellipse using ellipse by center point, okay. Guys, you're having exam after say some 1 month, so you may be forgetting all the concepts. So my recommendation is that you can refer my channel for revision purpose, okay, because I have done the problems both in sketchbook and in solid software, so that you can revise easily with minimal time. It doesn't take too much time for revision because the problems were done in a very stipulated manner, so that every student can understand it easily, and within very less time you can revise it, because you may be forgetting all the concepts like normal type, beta angle, like that, okay. So my request is that you can refer, because with respect to the playlist I have created all the content with respect to the VTU syllabus, right? Projection of points, projection of lines, or it can be projection of planes, projection of solids, okay, isometric projection and development of lateral surface of solids. So with respect to the playlist, I have created separate playlists. Say for sketching also separate playlist is there, and for this practicing in the system, that is using solid software, so that is also I have created separately. You can refer those videos, so it can be helpful. So no need to worry that you don't have enough time for practicing after the theory exams. You have only say one day. So it's better, what I recommend is that after your theory exam, say not like theory you can't able to revise in one day, say in between the theory exams, like you will be welcome to engineering visualization channel. Today we are going to solve problem number 2 in model question paper 2 of computer aided engineering drawing, okay. So it will be beneficial for you people if you need to watch this video until end, so that you can able to understand each and every step of this problem. And this is one of the important problem, that is problem number 2, that is in projection of solids tetrahedron. A tetrahedron of 50 mm side rests on one of its corners, such that edge containing that corner is inclined to HP at 50 degree and VP at 30 degree. So this is one of the special type of problem. So in this okay, this so the same problem I have taken from the solution book. Okay, like this we need to construct in the solid software. Okay, this is the same problem we need to construct. So just for the reference I've taken like this, the same thing we need to construct. Okay, it will be easier for me to construct it is. Okay, so go to solid software, draw xy line, write hpvp. Okay, and xy line. Okay, because the problems we are constructing in the first quadrant. Okay, we need to construct this triangular face. Okay, go to polygon by center, make sure the mental relationship should be on, select three sides, thickness 0.50 mm. With respect to edge we need to place it. Okay, same problem has been asked in the model question paper 2. Okay, so give the length 55, enter, it will change. Now draw the projection lines. So here we need to draw median lines. Two medians are enough to find out the center, since it is a tetrahedron. It is one of the pyramids, so we need to draw the all the three slant edges. Okay, now write the namings for it. ABC bow O1. Okay, draw the projection lines upward. Okay, in this we don't know the axis length is this tetrahedron problem. Just randomly need to draw, and from on this end, from the one end which is parallel to x, so you can see CY it is parallel. That's why we are cutting the arc from this end of length 55 mm radius. Cut the arc. Okay, now join it. Guys, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, you are going to get all the problems solved from the model question paper of the Vtu-Caed. Okay, so it will be beneficial for you. You can share this video in your WhatsApp group so that your friends and classmates can be benefited. So we are writing the front view notations: B dash visible, A dash not visible, O1 dash and O dash. Okay, next in second position it is nothing but inclination with the base edge here. Okay, now we'll select this front view and go to move command. So here we are rotating, so we need to copy along the xy line and then we need to rotate and give the angle. So for this base edge, so angle is 50°. So it is yeah, this is what the angle we get it. Guys, you follow this procedure. Okay, now project it downwards to complete the second position top view. Write down the notations. So first we need to construct the outer boundary line, guys. In the second position top view, we follow the same steps. So zoom in to get the exact point here. Okay, construct the dashed line as it is in the question. Now we need to find out the beta angle here. Okay, so mention the axis. So here in this problem they have given angle of inclination with the edges here, but the concept of beta angle is that it will be there with respect to axis, but it is one of the special type of problem. Okay, here in this angle of inclination they have given with respect to the edges for both HP and VP plane. That's why it is also the beta angle problem. Okay, angle 30 degree. So minus 150 if you give, it will take 30 degree. Okay, now here the slanted length you need to use, that is 55 mm. So go to arc by center. So take 55 mm length and cut the arc. Okay, now draw the locus line. So another length we have, that is slanted, is 35.16. So these two lengths are required. So one length already we have drawn. Now we need to draw an locus line here, horizontal dashed line. Okay, so cut second arc using arc by center. So just move the cursor on the first arc, you will get the reference point. Now type the radius 35.16 and enter and cut the arc. Now join this second point which I have cut it. Yes, zoom in and get the point. Okay, so just extend this line using extend to next command and find out angle, beta angle. So it is 51 degree. So we're getting an exact angle here, guys. We're doing correctly. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your classmates and friends so that they can be benefited. So using move command we have copied. So take the reference point of OC and place it on the angle line here. So place it pinpoint. You can zoom in when you're placing it. You can zoom in and place. Okay, so now draw the projection lines to complete the final position here. Okay, after writing the notations, you can join it first. Join the triangular face and then the slant edges. If any of the slant edges passing inside, that will be dashed line. So passing outside means it is continuous one. So the dashed line from here, from this end to here. Okay, and then finally we need to draw an axis. Okay, that completes the problem. Thank you guys. Thank you all for watching the video. So subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve question number 3 in the model question paper 3 of Vtu-Caed, computer aided engineering drawing. Okay, so make use of the video. You can watch till the end. You can able to understand each and every step of the problem. So here the problem number 3 of the model question paper 2, it is nothing but isometric problem. Here a sphere of diameter 50 mm rests centrally on a cube of sides 50 mm. Draw the isometric projection of the combination. It is nothing but the problem number 1. Okay, so you can see in this question, so we need to construct a cube. Above it we need to construct the sphere here. So first I'll be drawing an reference line. So please follow the step by step. You can able to understand the problem clear and easily. Okay, so reference line drawn. Okay, here we need to construct the cube first. So this cube of sides 50 mm. 50 mm means we need to consider 50 mm box. So here please consider the angles. So from this reference end, length will be 50, angle is 30 degree. Okay, again length is 50, angle is 180 degree, 150 degree, sorry. Then another angle is, again length is 50, angle is 210 degree. So like this we need to construct the box. Okay, now vertical height we need to give the height of 50 mm. One line I will draw, length of 50 mm. Okay, Then go to move command, creates a copy of it, or either you can directly do it like this. Okay, then 50 directly we can do. Angle is 90 degree. Okay, now construct the top face. So here the cube construction, it is done, guys. The cube we have constructed. Above it centrally we need to place the sphere here. So that is also having dimension 50. But guys, you know that sphere will be constructed with the actual scale, but the cube we need to convert into isometric here. Okay, so that is the important thing you should. Okay, you can keep it like this. Then you can show the angle. And this is one of the basic first problem of the isometric projection, guys, and this problem can be asked in the exam. Okay, so find out the midpoints. Height we need to find out. This is the center of the box. Center of the sphere will be find out. The height will be 25. Okay, now after finding out the height, we will convert into iso. Okay, so this step you remember, guys. Go to scale here, type here 0.816 or 823, can type it. Okay, now go to circle and draw here. That's what the center of the sphere. Now go to circle and draw circle of diameter 50. Enter. So that completes the sphere here. So always remember, sphere will be drawn with the actual scale, other solids will be converted into iso. So you can check the dimensions here. This will be 50 sphere actual dimensions, but if you check the dimension of the cube, it is less than 50. But after converting to iso, it is converted into less dimensions. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you, guys. Thank you all. Welcome to Engineering Visualization channel. So today we are going to solve problem number 4, that is development problem in model question paper 2 CAD. Okay, computer aided engineering drawing. Okay, you can watch the video till the end. You can understand each and every steps of this particular problem. So we are solving the problem number 4, that is development square pyramid problem in model question number 2. You can see square pyramid given, base 40, side and axis 60 mm long, has its base on HP and all the edges of the base are equally inclined to VP, and it's cut with an inclined plane 6. Okay, the same question which I have taken from the solution book. Okay, here it is easy to study and do the solution. Okay, we cannot just go and back like that, so that's why I have taken like this here. So here first we need to construct a square pyramid of base 40 mm and axis 65, and it is resting with edges of the base or equally inclined to VP. Equally inclined to VP means it is nothing but resting with the corner position. Okay, and then it will be cut by a section plane. So first we construct the top and front view of it, and then the section plane. Okay, step by step we are going to do it, so please watch it till the end. You can understand all the steps, okay, easily. So go to rectangle by center. Here the width and height we have to give, that is 40 and 40, and angle will be 45 degree. So this is how we construct the square with respect to corner position. Okay, show the dimensions, write down the namings for it. Write xy HPVV and draw the projection lines upward to construct the front view. So here top view notations can be written ABCD. Since it is a pyramid, that means we need to draw the slant edges, that is thick lines we need to draw here. If it is a prism means it should be thin lines. So you all should know the difference. So thick lines we have drawn. Write down O1. Okay. Now draw the projection line support to construct the front view. So projection line should be thin line, that is 0.13 mm. We should take thickness. So axis height is 65 mm. Take the same length. So construct the triangular face. Show the dimension of the axis. So front view, it is done. Now here we need to draw an section plane, that is truncated surface at an angle of 40 degree. Okay. So exactly midpoint we need to find out, because it is bisecting the axis, means exactly half 65 half is 32.5. So here at this point we need to draw an section plane at an angle of 40 degree. So the length can be anything, but here angle you have to show with respect to axis. It is given in the question, it is 45 degree, guys. So it exactly this, right? So this is a section plane. Now can mention the, so that upper portion I am going to make it okay lighter, in order to show that the lower portion has been the cut portion, the truncated surface. Okay. Now I'm mentioning the cut points here. So it is cutting the, so you can mention this front view notations: E dash, B dash, C dash, and D dash is not visible from the front view. O1 dash and O dash also can mention. I can mention the cut points. So here cut points we are mentioning with the numericals. So 1 is cutting the slanted JO, 2 is cutting the slanted BO, and C is cutting the slanted CO, and 4 it is cutting the slanted DO. Okay. Okay, mention the cut points like this. Then measure the slant edge dimension. So here you need to find out the slant edge dimension. Use 2 points. So here in the dimension they are showing horizontal, vertical, right? So this length also you can take, because that is also a slant edge length. Okay. Just for reference, I'm drawing the slant edge here because I have split it there. Now we're getting the slant edge length. Same length we got it. Now using this slant edge length, we will construct the development of it. Same for same length, we'll be drawing a line. Now we need to transfer all these cut points on the slant edge length. Okay, 1 and 4. This is important step, guys. You should do it. 2 and 4, and this is 1. 3 it is already there on the slant edge. Okay, and you need to measure this length because we need to cut the arc on the slant edge when we are drawing and this development, right? We should know these dimensions. The slant edge lengths we need to find out. So for this I'll be using split command to get the exact length here. Okay. So in the distance between command there is an option here. So distance between 2 points, if you select, so you can able to measure the dimension. Okay, this is important step, guys. You can make use of this particular command. So select these 2 points. This will give the slanted line. Same way from this end to from this end. So again you have to select this particular command. Again you need to, yes, like this you can measure. Yes, we got all the section point length on the slant edge. Now we will construct the same slant edge length here. After drawing a vertical line, we need to draw an arc using curve by center command. Okay, use arc by center command here. Yes, center point, and then draw an arc. Again here we need to use the arc again because 40 mm lengths we need to cut. Guys, in order to solve this problem it takes a lot of effort, so please make use of this video and subscribe to my channel and share to your friends and classmates so that they can be benefited. I am solving this model question paper because many of the students have been requested me. That's why I'm doing it. If you found this video very helpful, you can super thanks. There is an icon in the YouTube as you're watching the video. There is a little bit like sharing like button, but after that there is a particular icon like heart wherein you can, if you want to donate to this particular channel, you can donate it by super thanks. It starts from say 40 rupees. How much you want to pay, you can do it. There is no problem. If you found this video helpful, you can do it. Okay, you can join like this. Connect all the arc cut point which you have cut it, right, using vertical lines. Okay, like this you can connect it. If you're finding any disturbances during the video, so you can neglect it, so concentrate on the video so that you can able to practice it. Okay, so like this you can construct, because it is having four since it is a square pyramid. Okay, so join it like this. So dimension we can measure it and give the naming for it: capital B, capital C, capital D, and capital E. Okay, and A again. Now the cut points we should mention the dimensions which I have already measured for on the slant edge. Okay, A1 the same length arc we should cut. Similarly for 2 and 4 it will be the same length, and for 3 it is the length which we measured. Okay, go to arc by center and type that same radius for. Welcome to engineering visualization channel. Today we are going to solve model question paper 3 VTU computer aided engineering drawing. I welcome all of you students for this particular session. So in this particular video we are going to solve problem number 1 in model question paper 3. Okay, so you need to understand. So here in the model question paper 3 they will be giving a question that is equilateral triangle problem with beta angle. Okay, So watch till the end. You can able to understand each and every steps in the problem. You can see equilateral triangular lamina of sides 50 lies with one of its on HP. The lamina makes 45 degree to HP and one of its medians is inclined at 45 degree to V. Okay, here angle of inclination they have given with respect to median. That means it is an beta angle problem. So in this problem they have considered 50 Okay, I will not consider 50. I'll take for showing purpose I will take 25 and then I'll construct. Okay, so beta angle problem. So I'll show in the solid software. Guys, if you want to see the same type of problems like model question papers, all the types of problem, please subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So first I'll writing then xy line, writing HPVP since it is lying in the first quadrant. So go to polygon by center and select number of sides as 3, give number of sides 3 and resting with respect to edge. Okay, now go to smart dimension, select the vertical edge here, give 25. I'm showing this problem in 25 dimension. Okay, the same thing you can do it in the exam for 50 So based on the question given, guys, you need to do it. Okay, but for showing purpose I'm doing it for 25 Okay, so the procedure will be same. So draw the projection lines to complete the top view. If you have any doubts or queries regarding this subject, you can comment me or you can WhatsApp me, because I have shared the WhatsApp number in the YouTube channel. Okay, and if any problems you are not able to do it, you can personally share to me in the WhatsApp group so that I can help you. Okay, in solving it I can share you personally in your WhatsApp group. Okay. Guys, this is one of the scoring subject wherein you need to understand the concept and practice. Okay, little bit of practice so that you can score more marks in this. Okay, in this semester you will be having question paper coming from the VTU. Okay, so what I recommend you people is that you go through all the types of problem. Okay, first you know how to construct them and then concept and then practice. Okay, so like that you can solve this subject and score this subject very easily. Okay, for similar type of videos if you want, okay, related to video computer aided engineering drawing, you can subscribe to my channel. Okay, angle of inclination here I'm taking 40, it is 45 given. With respect to that you can take that. Okay, the procedure will be same. Now we need to do the beta angle here. So median we need to draw. Okay, so two medians we need to draw here for the first and second diagram, and we need to measure this length because angle of inclinations we need to do it for the median to find out the beta angle, right? So go to arc by center and cut the first arc of 21.65. Cut the arc. Now draw the locus line. Let's draw the locus line here. Then go to arc by center here. So take second arc length 15.31. Okay, from this reference point, type radius 15.31, enter and cut the arc. Okay, now join. So just take this move command, take this reference point, so place it on this reference point. Go to rotate command and take this length and rotate and place it exactly here. Yes, zoom in. Okay, zoom in and place it. Okay, now extend this angle line so that you will get beta angle. So this is the procedure, guys, to the beta angle. Okay, So now project it effort to complete the final position. Guys, thank you all. Thank you for watching my video. So you can join to my channel by only a less price of 119 rupees per a month, because exams are approaching. If you want to have any doubts or you want to revision, you can ping me in my channel. Okay, and after your exams you can cancel that recurring amount. Okay, so I encourage you people to join to my channel by paying 119 rupees. Then after your exams you can cancel it. So that's an easy way. Thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 from projection of solid in model question paper 3 VTU computer aided engineering drawing. So I want you people to watch the video till the end so that you can able to understand step by step procedure how we are going to complete this projection of solids. In that we have the hexagonal prism problem with bit angle. Okay, so you need to follow each of the steps one by one. You can see in this video I am able to solve this problem within less than 15 minutes. Okay, so what is given in question? Hexagonal prism 25 mm side of base and axis 60 is resting on one of its edges of the base on HP plane. Draw the projection of the prism when the axis is inclined to HP at 45 and VP at 30 degree. That means angle of inclination in this problem they have given with respect to axis for both HP and VP plane. So that means it is an bit angle question. Okay, that means in this problem we need to find out the bit angle. Okay, first we need to, okay, in order to understand this problem completely and want to see the similar type of problems, okay, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, now the same problem I'll take from the solution book like this. Okay, like this we need to construct in the solid software. Okay, why I'm completing this problem in solid software means, so 80% of your marks is there in the solid software, that's why I'm not doing the sketching. Okay, xy line it is written vphp. Now we need to construct the hexagon using polygon by center command with respect to the edge here. So construct the hexagon, take smart dimension, give the length 25, it will change. Okay, now write the notation, top views and bottom view notations. Top views notations are written with ABCD and bottom face notations are written A1 B1 C1 like that, but it should be written within brackets. So here we need to find out the center of the hexagonal prism. So for that at least one or two lines need to be drawn, because since it is a prism, to find out the center of the axis no need to draw all the lines. And here inside of this hexagon we should be drawing the thin lines. No need to draw the thick line, thin line should be drawn here. One or two lines is enough. Okay, you can see in this problem I have drawn the three thin lines. Okay, since it is a prism we should be drawing only the thin lines, not the thick lines, and mention O1 and close the bracket. Now draw the projection lines upward to complete the front view. So draw the projection lines upward here now. So axis of the prism it is 50 mm. 50 length. Okay, enter. There is also 50 So okay, so write the front view notations, so which are visible from the front view, so mention it. So from the front view, A dash, B dash and C dash visible, D dash, E dash and F dash not visible. So not visible means we should write within brackets. Same way for the bottom face also we write the same thing. So now we need to copy the same diagram using move command. Okay, and we need to incline with the base head. So inclination to base head is given. So actually they'll give angle of inclination to the axis, but we need to incline with the base edge inclination. Okay, it will be easy in order to do the inclination. So use the move command, creates a copy, slide along the xy line and go to rotate and take the base edge inclination. It is 45 degree, so incline 45, so it has been inclined. Okay, now extend the axis, find out the angle and project downward to complete the second position, top view. So draw the projection line downward here. Draw the projection lines downward to complete the second position, top view. Guys, subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications. Okay, write down the namings now. First I'll start from the bottom face. Now I'm writing for the top face, that is ABCDEF. Okay, now first we know that to construct the second position top view, first we have to draw an outer boundary line. Guys, you can join to my channel by rupees 119 per month, and then you can cancel after the examination. Now from the top face it is visible. So complete the hexagonal face, it is visible from the top face. So drawing the hidden faces with the dashed line. Okay, finally there is an axis. You can join from O1 to O. So it is in beta angle problem. We need to find out the beta angle in this. So the procedure is simple. You need to draw an angle line first. So angle it should be drawn for 30 degree. Okay, you can modify it just by doing like that. Okay, select this entire thing and then you can move it. First arc length of 50 mm we have to cut. Okay, 50 mm cut the arc. So draw the locus line. Now take this length of O1, 35.52. So cut this second arc length on the locus line. Then join using axis. Now we need to copy this second position top view and transfer using move command. Okay, project it upward to complete the final position. Thank you all. Thank you for watching the video. You can subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching my video. Complete the final position. Welcome to Engineering Visualization channel. So today we are going to solve question number 3 in the model question paper 3 of Vtu-Caed, computer aided engineering drawing. Okay, so make use of the video. You can watch till the end. You can able to understand each and every step of the problem. So here the problem number 3 of the model question paper 2 is nothing but isometric problem. Here a sphere of diameter 50 mm rests centrally on a cube of sides 50 mm. Draw the isometric projection of the combination. It is nothing but the problem number 1. Okay, so you can see in this question, so we need to construct a cube. Above it we need to construct the sphere here. So first I'll be drawing an reference line. So please follow the step by step. You can able to understand the problem clear and easily. Okay, so reference line drawn. Okay, here we need to construct the cube first. So this cube of sides 50 mm. 50 mm means we need to consider 50 mm box. So here please consider the angles. So from this reference end, length will be 50, angle is 30 degree. Okay, again length is 50, angle is 180 degree, 150 degree, sorry. Then another angle is, again length is 50, angle is 210 degree. So like this we need to construct the box. Okay, now vertical height we need to give the height of 50 mm. One line I will draw, length of 50 mm. Okay, then go to move command, creates a copy of it, or either you can directly do it like this. Okay, length 50 mm directly we can do. Angle is 90 degree. Okay, now construct the top face. So here the cube construction it is done, guys. The cube we have constructed. Above it centrally we need to place the sphere here. So that is also having dimension 50. But guys, you know that sphere will be constructed with the actual scale, but the cube we need to convert into isometric here. Okay, so that is the important thing you should. Okay, you can keep it like this. Then you can show the angle. And this is one of the basic first problem of the isometric projection, guys, and this problem can be asked in the exam. Okay, so find out the midpoints. Height we need to find out. This is the center of the box. Center of the sphere will be find out. The height will be 25. Okay, now after finding out the height we will convert into iso. Okay, so this step you remember, guys. Go to scale here, type here 0.816 or 823, can type it. Okay, now go to circle and draw here. That's what the center of the sphere. Now go to circle and draw circle of diameter 50. Enter. So that completes the sphere here. So always remember, sphere will be drawn with the actual scale, other solids will be converted into iso. So you can check the dimensions here. This will be 50 sphere actual dimensions, but if you check the dimension of the cube it is less than 50, but after converting to iso it is converted into less dimensions. Okay, thank you all. Thank you for watching my video. Subscribe to my channel and share to your friends and classmates so that they can be benefited. Thank you, guys. Thank you all. Hello guys, welcome to Engineering Visualization channel. Now today we are going to solve model question paper 3 Vtu-Caed and problem number 4. Okay, so many of the students have been requested me for solving model question papers from VTU, because this time we will get the question papers from VTU only. Before that, the internal and external examiners are preparing the question paper, but from this semester the question paper you're getting from the VTU. Okay, so I'm trying to solve the question papers, guys. Try to get the help more out of these videos. Okay, so here the problem number 4: pentagonal prism of base side 30 mm and axis length 60 mm rest with its base on HP, and at the end an edge of the base inclined at 45 degree to VB. So that means we need to place the pentagon with respect to an angle of 45 degree to VB. So it is cut by an plane perpendicular to VP, inclined at 40 degree to HP, passing through a point on the axis at a distance of 30 mm from the base. Okay, so develop a remaining surface of the truncated prism. Okay, so first we need to construct an pentagon here. Okay, and then we have to place that pentagon at an angle of 45 degree to VP. Okay, that's how we have to proceed with this problem. Okay, so draw an XY line, and here pentagon will be constructed, and its edge has to be placed on 45 degree angle line. Okay, so for that, first I'm drawing an 45 degree angle line. So angle line of 45 degree is drawn. Now we have to go to polygon base center command. So construct the pentagon with the edge. So here number of sides we need to take 5. Place it with the edge and go to smart dimension and give the dimension now. So dimension of 30 mm. Okay, now you place the pentagon with respect to the edge on this 45 degree angle line. So go to move command and select this pentagon with respect to the end corners. Now go to move rotate command and place it with respect to the edge. Okay, so now it is done. So the first position top view it is done. Now we need to give the naming for this. Okay, for the naming purpose I'll be writing only the top face notation. I'm not writing bottom face because here I'm concentrating more on the construction part. After giving the namings, we need to draw at least two or three perpendicular bisectors, okay, to get the center point. So after drawing the front view, so we need to draw the projection line for this end also. Okay, so draw a length of 30 from the base. Okay, so at this point we need to draw an section plane. So angle, you can see here, angle of 40 degree. You can draw angle line like this or like this on the both the sides. You can draw, no problem. I'll draw here this side. Okay, randomly I'll draw a line, then after that I'll change the angle. So this problem, guys, I have not did in development of lateral surface of solid. You can refer this particular problem, because this problem in pentagonal prism I have not did, so it can be helpful for you to refer in the exam. So angle of inclination is 40 degree. Now you can extend this section plane. Okay, so section plane has been drawn at a height of 30 on the axis at an angle of 40 degree. Now you can write down the cut points. Okay, one, it is on the vertical edge of AA, and 2, it is on the vertical edge of BB, and 3, it is on the vertical edge of CC, and D, it is on the vertical edge of DD, and 5, it is on the vertical edge of EE. Okay, so software, it is taking a loading little bit of slow. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates in the WhatsApp group so that they can also be benefited from this. Okay, we got the cut points. Now we need to draw the development of this. We know that prism will be drawn using parallel line method, so we'll be drawing the parallel lines here. Okay, so one vertical line you can draw, and then there are 5 faces in the pentagon, so we can draw at a distance of 30 Okay, can give this as a go to offset command and select this particular line, and then offset at a distance of 30 can give the distance now 30, and click on accept. Okay, 5 lines we need to draw, 5 faces. Okay, now just wherever we got the cut points, right, from there we need to draw the horizontal lines we need to draw from 1. Can give the naming here in capital B, capital C, capital D, and A. Yes, the cut point of 1, it should be on the vertical edge of A. That's why I'm just extended, so you can mention now. Same 2, it is on the vertical edge of B. phi, it should be vertical on the vertical edge of E. Okay, and then 3, it is on a vertical edge of C. 4, it should be on the vertical edge of D. So now we need to write the cut points names. So 1 on a vertical edge of A, and 2 it is on B, 3 it is on C, 4 it is on D, and 5 it is on E. Now we need to connect this all these points using straight line. You can click on the bell icon because I'm going to upload all the model question paper solution to this channel. Okay, make use of it for the exam. And I always tell that for the revision purpose you can refer to this channel, because during exam time you are going to forget all the concepts. What is the concept you have been used for normal type or beta angle or appears to be, okay, whether it is in planes, solids, or in isometric. Development, for the development purpose, it is the best channel, because in many of the channels you may see they maybe have done only some 2, 3, or 5 problems. Okay, but in this channel you get almost all the types of problem. So I have taken so much of hard work for you people. Okay, make use of the videos. You can take any of the problems, either it is cone, cylinder, prism, pyramid. All the types of problems have been solved in this particular channel, so make use of it. Okay, and if you find this channel helpful, you can subscribe and hit on the like button and hit on the bell icon for the latest notifications. Think problem is completed. Thank you guys, thank you all, thank you for supporting this channel, thank you for watching it, and make sure you share in the WhatsApp group of your classmates and friends so that they can also be benefited from this particular video. Okay, thank you all, thank you for watching it. Welcome to Engineering Visualization channel. So today we are going to solve model question paper 4 problems. Okay, so watch the videos till the end. You can able to understand all the 4 problems. So each one of the problem I'm going to solve using solid software. Okay, all the 4 problems. So in this question number 1 given points and lines problem, second one is solids, third is isometric, fourth is development. So subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications, and hit on the like button. Thank you all, and watch the video till the end. You can able to understand all the steps. Thank you all. Projection of point problem. Okay, this is a solid edge 2024 student version. Okay, first I'm going to draw an xy line. Okay, so we can make use of this video so that many of the students have been asked for the solving the model question paper of the CAD. Okay, for them I'm doing this. So guys, please make use of it. Okay, subscribe to my channel and share to your classmates and friends so that they can be benefited. Okay, so here with respect to the question here, so in the question what they mentioned here, so it is resting on the HP plane, say resting on the XY line. So you can see the question. A point A is on HP means it is nothing but the front view. That's why I have put a point and mention A dash. Okay, and now the length we should consider. So here the point, it is the top view lying in the first and fourth quadrant. In both first and fourth quadrant, it is lying below the XY line. So that's why I'm drawing the length of 30 mm. So below the XY line. Okay, you can just see first and fourth quadrant. So it is below the XY line. That's why I'm putting it and mentioning it as A. Okay. Now after that, see the question. Can change the thickness here. Okay, this is the new version of the software. That's why I'm getting a little bit of time, because the commands were of different type. Okay, so if you want this software, I can share this. Okay, this is the, for top A it is 35 mm drawn, and then if it is a another point B is on VP. On VP means it is nothing but the on VP means it is nothing but the top view, and below HP. So below HP means we don't know how much distance it is. Okay, what they mention here, it is the line joining the front views makes an angle 30 degree to XY, while the line joining the top views makes an angle 45 degree with XY. So that means we should connect with the top views with an angle of 45 degree, front views with an angle of 30 degree. Okay, that's what given in this problem. Using this sentence we have to draw. So what I'll do is, here I'll be connecting the top views at an angle of 45 degrees. Okay, so from the top view I'll be drawing an angle line for a length of 45. So here just by randomly we can draw, and then we can change the angle here. So first I'm drawing one line. Okay, and I can change the angle here. Can change the thickness. Okay, so select the line and select its thickness as 0.13. Okay, now here I'll change the angle. Now you can see here I'll go to angle between. So before that I'll be drawing one smaller horizontal line here from at the top A. Okay, so go to angle between and select the angle between these two lines, and angle you're getting in. Now we can modify, change it to 45. Yes, now it has been changed. Okay, this is what the top view connecting the angles. Okay, an angle of 45 degree. So you can see the question here. So another point B is on VP. On another point B is on VP means nothing but the top view, and it should be drawn on the XY line. Okay, so we know that the top views are connected by an angle of 45 degree. So from the top view of A, already we have drawn an angle line at an angle of 45 degree. Now I'll put the point. So that top view we should be marking on the line passing the 45 degree and on the XY line. Okay, so the intersection of this 45 degree line and on the XY line. Now what I'll do is, we'll be drawing another line which is of angle 30 degree. Okay, that is for front views, like this. Yes, downward I'll be drawing it. So just randomly I'll draw it, and then after that I'll change the angle. Just randomly can draw here. Don't worry about the length. Now we can change the angle. So this angle should be 30 degree. Okay, now you can see the top view on VP means nothing but the top view. It should be drawn on the XY line. Okay, another point is on VP and below HP, and they have not mentioned any distances, right? So you can put the point here. Go to point and just change the thickness to 2 mm. Okay, and here I can put yes here. Now vertically downward is another point. Now we need to draw with the vertical line here. Yes, you can change the thickness of this line. So I'll be making it as 0.13 mm. Change it to 0.13 mm here. Okay, you can see here we should mention the points here. Okay, now mention the views here. So here this point is exactly B, small b, and this is B dash. You can see the top views are connected by angle 45 degree and front views are connected by angle 30 degree. Now we have to find out this distance. You can see what they mentioned. Find the distance of the point B from HP. Okay, so that distance we need to find out. So we just measure it using smart dimension. So that completes the problem, guys. Subscribe to my channel and like the video. So PQ given 85 mm long, has its end P 10 mm above HP, 15 mm in front of VP. The top and front view are given, that is 75 and 80 mm. Using this we have to construct. So initially I have drawn an XY line here, VPHP drawn. Now we have to draw these locus lines. I'll be using offset command. So select the XY line and give the dimension 10 mm. In the same way again you select XY, give the dimension here 15 mm. Okay, now we can see that the apparent length given here. So apparent length okay, so this is we consider as a end points. Using this 75 and 85 mm, we have to draw the true length. First I'll be taking this apparent length in top view, okay, giving 75. So from this end I'll be drawing a vertical straight line. So from this end I'll be measuring for length of true length we have to give. Okay, go to arc by center, give true length 85 and cut the arc. Okay, because apparent length when it is rotated and projected we get the true length here. Okay, now you join from this end point to here. Okay, now at this end point of the line we can draw the locus line. So we can measure the length. It is 85, that is true length. So here at this end point you can draw the locus line. Same way the apparent length in front view dimensions we have to use. So the length given it is 80 mm, 80. Again go to arc by center and take the true length 85 mm. From the end point you cut the arc. And we join this cutted point with the end point, you will get the another true length. So here at the bottom below the XY line also we have to draw another locus line. Now go to arc by center. By measuring this 75 and 80 mm apparent lengths, you have to draw an arc to draw the apparent lengths. First select the 70 mm length, cut an arc. Same way for 80 mm length, cut an arc. Okay, now go to line and select thick line, 0.50 mm thickness. So apparent length you always show with the thick line. Okay, now we can measure the lengths and angles. You can see this, that is the apparent length in front view 80 mm and apparent length in top view it is 75 as it is given in the question. Okay. And you can show the angles here. You can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Welcome to Engineering Visualization channel. Today we are going to solve problem number 2 from projection of solid in model question paper 3 VTU computer aided engineering drawing. So I want you people to watch the video till the end so that you can able to understand step by step procedure how we are going to complete this projection of solids. In that we have the hexagonal prism problem with beta angle. Okay, so you need to follow each of the steps one by one. You can see in this video I am able to solve this problem within less than 15 minutes. Okay, so what is given in question? Hexagonal prism 25 mm side of base and axis 60 is resting on one of its edges of the base on HP plane. Draw the projection of the prism when the axis is inclined to HP at 45 and VP at 30 degree. That means angle of inclination in this problem they have given with respect to axis for both HP and VP plane. So that means it is an beta angle question. Okay, that means in this problem we need to find out the beta angle. Okay, first we need to, okay, in order to understand this problem completely and want to see the similar type of problems, okay, subscribe to my channel and hit on the bell icon for the latest notifications. Okay, now the same problem I'll take from the solution book like this. Okay, like this we need to construct in the solid software. Okay, why I'm completing this problem in solid software means, so 80% of your marks is there in the solid software, that's why I'm not doing the sketching. Okay, x5 line it is written bphp. Now we need to construct the hexagon using polygon by center command with respect to the edge here. So construct the hexagon, take smart dimension, give the length 25, it will change. Okay, now write the notation, top views and bottom view notations. Top face notations are written with ABCD and bottom face notations are written A1, B1, C1 like that, but it should be written within brackets. So here we need to find out the center of the hexagonal prism. So for that at least one or two lines need to be drawn, because since it is a prism, to find out the center of the axis no need to draw all the lines. And here inside of this hexagon we should be drawing the thin lines. No need to draw the thick line, thin line should be drawn here. One or two lines is enough. Okay, you can see in this problem I have drawn the three thin lines. Okay, since it is a prism we should be drawing only the thin lines, not the thick lines, and mention O1 and close the bracket. Now draw the projection lines upward to complete the front view. So draw the projection lines upward here now. So axis of the prism, it is 50 mm. Length. Okay, enter. That is also 50 mm. So okay, so write the front view notations, so which are visible from the front view, so mention it. So from the front view, A dash, B dash and C dash visible, D dash, E dash and F dash not visible. So not visible means we should write within brackets. Same way for the bottom face also we write the same thing. So now we need to copy the same diagram using move command. Okay, and we need to incline with the base edge. So inclination to base edge is given. So actually they'll give angle of inclination to the axis, but we need to incline with the base edge inclination. Okay, it will be easy in order to do the inclination. So use the move command, creates a copy, slide along the XY line and go to rotate and take the base edge. Inclination, it is 45°. So incline 45, so it has been inclined. Okay, now extend the axis, find out the angle and project downward. To complete the second position, top view. So draw the projection line downward here. Draw the projection lines downward to complete the second position, top view. Guys, subscribe to my channel and share to your friends and classmates so that they can be benefited, and hit on the bell icon for the latest notifications. Okay, write down the namings now. First I'll start from the bottom face. Now I'm writing for the top face, that is ABCDEF. Okay. Now first we know that to construct the second position top view, first we have to draw an outer boundary line. Guys, you can join to my channel by rupees 119 per month, and then you can cancel after the examination. Now from the top face it is visible, so complete the hexagonal face. It is visible from the top face. So drawing the hidden faces with the dashed line. Okay, finally there is an axis. You can join from O1 to O. So it is in beta angle problem. We need to find out the beta angle in this. So the procedure is simple. You need to draw an angle line first. So angle it should be drawn for 30°. Okay, you can modify it just by doing like that. Okay, select this entire thing and then you can move it. First arc length of 50 mm we have to cut. Okay, 50 mm cut the arc. So draw the locus line. Now take this length of O1, 35.52. So cut this second arc length on the locus line. Then join using axis. Now we need to copy this second position top view and transfer using move command. Okay, project it upward to complete the final position. Thank you all. Thank you for watching the video. You can subscribe to my channel and hit on the like button and hit on the bell icon for the latest notifications. Thank you all. Thank you for watching my video. Complete the final position. Is placed cordially on top of a regular hexagonal prism of base side 30 and height also out of the axis 60. That means first I should construct this hexagon. That is first I have to draw the orthographic top view. So remember it, for the polygons such as triangle, pentagon and hexagon, we should always construct the orthographic top view because you require box dimensions in order to construct it. Okay. Change the dimension to 30. Now using this box dimension, okay, we have constructed the box. I have to show the box dimensions. Okay, so for the hexagon box with the box dimensions constructed, now I'll be constructing the orthographic of it. Take a reference line. Okay, so from this reference line, so construct a box for a length of 51.96. that is what the first length, 96, and angle 30 degree. Okay, the second length is 60, angle is 150. Again the length is 51.96, angle is 210. Okay, now join. So box it is constructed. Now we have to cut the arcs. Okay, for a length of 51.96, we will be cutting an arc of 25.98. Take the radius and cut the arc. The same way, in the opposite side also I will be cutting for the same arc length. Okay, that is 25.98. Give the radius 25.98 and cut the arc. Okay. After that, at the edges we have to cut a arc length of 15 mm from the corner ends. Okay, 15 mm. From this side also 15. Cut it. Same way from here also. Cut it for 15 mm. Same way you can do it here. Radius of 15. Okay, now go to thick line. Now connect all these points. Okay, let's complete the bottom of the hexagon. Now we have to consider a vertical height of 30 mm. You can see 30 mm length of the axis, so height should be 30. First I will draw the vertical line from one reference end 30. Okay, we go to move command, it's a copy, select the corner end and then place it with respect to all the corner points. Okay, now using continuous line I'm going to join all these corner points. Okay, so that completes the hexagon. Now exactly at the center of it we have to place the cone here. Okay, so to place the cone here separately, what I'll do, I'll be constructing the hemisphere, that is ellipse of dimension 40 separately. You can see a right regular cone on base side 40 mm. Okay, on one side I'll be constructing by taking length. The length will be 40, angle is 30, and again length is 40, angle is 150, length is 40, angle is 210. Okay, good morning all. So in this problem, this is problem number 2 from solution book. So in this problem we have to construct a square prism of base side 30, axis length 60. Okay, resting on HP with all the vertical bases inclined to it. Okay, so we have to construct the development of this. Okay, first I will be constructing a square prism, okay, of dimension 30. So before that I will be drawing an XY line first. Okay, so here you can see I am drawing a square here, square of dimension 30 and angle 45 degree. Okay, you can show the dimension for one side, you can write the namings. So we have to write the namings in small case letters. Okay, so doing the projection line, so drawing the projection line here. Okay, the front view axis length it is 60 mm. Yes, it is a square prism, means we have to get a rectangular face in the front view. Okay, so the front and top view of the square prism, front and top view of the square prism, it is done. Now we can show the dimension. Okay, so now we have to draw the section plane which is there at a height of 50 mm from the base. Okay, and it is exactly cutting the axis at a height of 50. So for that I'll be drawing a 50 mm line from the base, exactly from the center on the axis. I'll be drawing another 50 mm line. Okay, so go to line. So from the bottom I am going to draw, that will be convenient. Okay, 50 minus 10, 60 minus 50 means 10, but I will be drawing from the bottom. Okay, so from the bottom 50 mm length, so I have drawn one line for reference, and then I am drawing a section plane, taking this as axis plane, now giving the angle 60 degree. Okay, so that's what I can see, that angle of inclination will be 60 degree here. So type 60 and enter. Okay, so after this go to next and extend this line. Okay, this is where it is cutted. Okay, this is how it is cutted. Now we can show the angle for this section plane. Okay, angle of inclination it is 60 degree. Now we have to we can give the naming here. So that is 1, it is where it is cutted. Again on the A point it is 1, again here same on the A edge. Now 2, point number 2, it is falling on a vertical edge B. Okay, and then point number 3, you can see it is not falling on the C, it is falling somewhere in between B and C. Okay, somewhere in between. That's why I'll be drawing a projection line from this intersection of these 2 points. By projecting it, you can see this is not falling on the B, it is falling in between B and C. So that's why we have to draw another line here. I'll be making that line as a continuous line. So we can give that is 3, and here you can see again if I write the point number 4, so that is not falling on the D, it is falling in between C and D. Okay, that's why point number 4. Then point 5, it is falling on the exactly on the vertical edge D here. Okay, now we have done with the namings. Now we have to project it. You can see that. So we have to project it. Okay, so so I can use the split command to highlight only the retained cut portion. Okay, so for that I'll be using the this split command. Using the split command we can split it exactly where we want to make the lines dark. Okay, we have to dark only the portions which has been cut by the section plane, the retained cut portions. Okay, so other lines I'm going to make it thin lines. Okay, thin lines. By selecting these lines, I'll be making it as thin lines. Okay, now we got it, the cutted portion. Now we have to do the development. So draw the projection lines from here. Okay, so draw the continuous line here. Now we take vertical edge, because this is a parallel line method, because it is a prism. So draw vertical line. Anywhere you can take a straight vertical line. Okay, now here you can see the dimension, it is 30. Totally there are 4 faces in the sphere prism. So using the offset command, I will be giving the distance of 30, and then I will click for 4 times. Okay, I will get the 4 faces here. I will make all these lines as continuous. Okay, now we can see by projecting the from point 1, so I am getting point number 1 on AA. So okay, so I can do that. So you can see first we have to write the namings A, B, C, D, capital A, capital B. So that indicates we'll get the exact vertical edges A, B, C, D, A. And now we can give the namings 1 and 1 we are getting on the vertical edge A. Okay, and the vertical edge B we having a point number 2, that also we can project it. Point 2 and 5 we are getting on the same point, but I'm not getting the intersection here. So I can use the split command here, so that I can get the exact point here. I'll go to split command and split it exactly where the section plane is cutting. Okay, so now I'm getting the exact point. From here I'm going to project it hard. Welcome to Engineering Visualization channel. Today we are going to solve model question paper 5, VTU computer aided engineering drawing. Okay, here in this question they are given question number 1, it is rectangular lamina. Question number 2, hexagonal prism which appears to be, and here question number 3 they have given to complete the orthographic projection of this object. Okay, so for this particular problem I have done the top, front and side views, so please go through. And problem number 4, it is cube problem. Okay, you can see this. In order to see more videos like this, you can subscribe to my channel and hit on the bell icon and watch till the end. Width give 30 and height 20, and place it with the shorter edge here on the VP plane. Okay, so measure the dimensions. Okay, write down the notations and draw the projection lines to complete the top view. Okay. So here B and C are not visible. That's why B and C written within brackets. Select the top view, go to move command, creates a copy of it and slide along the line. And now we can give the inclinations. So inclination to the VP. So here I'll give angle of inclination 30 degree. Okay. So inclination below the XY line means minus 30 we have to give. Okay. Draw the projection lines to complete the second position front view. And write A dash, B dash, C dash and D dash. Go to thick line. Okay, second position top view completed. And trim it off these extra lines. You can see now longer side of the plane is inclined at dash degree to VP. That means we should take that longer edge and we have to give the angle of inclination here. First I'll be drawing an angle line. Okay. Angle of inclination here I'll give 45 degree. I'll select this second position front view. Okay, creates a copy of it and select the vertical edge here. I'll select this B dash. Go to rotate. Select this B dash to C dash and place it on the angle line. Then project downward to complete the final position. Complete the final position by joining with the thick line. So this completes the problem. Problem number 6 from the respect to edge here. So hexagon of dimension 25. So make sure this icon maintain relationship has to be on. Then use polygon by center, 6 sides. Okay. With respect to edge. So give the naming C, D, E, A1 in bracket. After this, we draw the thin lines to find out the center of the axis. Okay, that is diagonals we are going to draw. It is O. Okay, now here axis length is 50 mm. So it is equal to C B dash, C dash, B dash, dash in bracket, similarly B1 dash, C1 dash, B1 dash equal to C B1 O1 dash and dash and O dash also not visible. Okay. So now 45-degree inclination to HP. So we are going for base edge inclination. T minus T5 equal to 45. So we have to incline this with respect to the base edge. Okay. Angle of T5 degree. Then extend extend command. Can extend the axis and find out the angle of inclination. A1, E1, C1. So here projection line.
Sir, hello. Sir, one email form was there. The person came. Sir, how can we not be please approve. Please ask sir, members. Sir, okay,
So first we have to construct an outer boundary line. This eccentricity is visible from here. And this rectangular face also visible. This hexagonal base not visible from the top view. So it is written with the shade line. Okay. Here from this slanted rectangular it's also not visible. You can show part of the line here from here to here. Now 40-degree angle line. So angle we have to give 20-degree angle. Minus so Q minus
171 thank you ಸರ್ ಆಕ್ಚುಲಿ ನಾನು ನಡೆಸಬೇಕು ನಮ್ಮ ಇವ್ರು ನಡೆಸಬೇಕು
we have to have here 40-degree 40-degree minus 40. Then we have to select it. Okay. Axis line here. So select this diagram to create it. So I can take it a little lower. and give the naming. Another projection line. V1 dash, V1 dash. So here are two nearest point to X velocities E and F. Okay, E to D, E to F, and F to J, and F to F1. Like that, first we construct the dashed lines. Now rest of the diagram it is written with a continuous line. The slant edges. Finally, axis. Good morning, all of you. So you can see in this, this is what the isometric component given. So we have to construct the isometric views, that is front view, top view, and side view. You can see this is your isometric. Isometric means it is nothing but the 3D view of the component. Okay, wherein it will show the dimension both in x, y, and z direction. Okay, isometric means it is a 3D component. Okay, but the orthographic means, so it is the individual views. You can say the top views, side view, and front view. So the separate views what we get, that what we called as your orthographic views. Okay, here we need to convert these isometric into orthographic. Okay, that's what we have to do in this problem. Okay, you can see there is a front view exists, there is a front view, side view and top view exists. So we have to analyze each of these views and we need to construct all these front view, top view and side view. Okay, they have mentioned in the question front view looking from X means that is your front view. So then you can see there is a top view exists. Okay, and there is a side view. So we will be constructing each of these views one by one. Okay, so first I'll be constructing XY and X1 Y1 line. So thereby I'll be dividing the regions for both top view, front view and side view. Okay, so here I'm drawing XY line. So I'll be mentioning XY. Okay, I'll be mentioning X1 Y1, that is profile plane here. Okay, that is X1 and Y1. Okay, now we need to analyze. So we can write this here. Here I will be constructing the front view. That's why I've written FV. And here I will be constructing top view. And here side view. So that's what the short notations. Otherwise I will write the full thing. Front view. Okay. Top view. Top view. And this is our side view. Okay. Now we have to analyze the isometric. You can see in this isometric. So this is our front view. So which are the faces visible from this front view? We need to analyze. I will write it. This is our front view. So this is our top view. So we need to look at this component from the top view. That's why it is top view. And this is where we get the side view. Okay. This is we have the side view. Okay. So you can mention the shortcut also. Okay. In the next problems, I'll be mentioning shortcut. That's why I'm writing there. Okay, you can analyze from the front view which are the faces visible here. You can see I'll be constructing there front view, top view and the side view. You can see the front view and side view always adjacent to each other. Okay, adjacent to each other, and then top view and front view will get in a vertical collinear line or a plane. Front view always adjacent to the side view. In order to connect the top view with the side view, we draw 45-degree angle line. Okay, so now I'll be analyzing the front view. So to analyze the front view, which are the faces visible, I'm going to shade it. Okay, I'm going to shade it. So this is how it is easy for us to identify which are the faces visible from the front view. You can see that L shape is visible from the front view, and then this rectangular face also visible from the front view. I'm shading it. Okay, and this face also visible from the front view. Okay, so these three faces are visible from the front view. We need to draw. You can see the length of it is having 104 mm and the height it is having 48 mm. So that means we can construct one rectangle with 104 and 48 mm with thin lines. Okay, so I'll be drawing a line here, horizontal line for 104 mm. You can see all these dimensions were in mm. Okay, so 104 mm. So and the height here we should get, that is 48 mm. Okay, so mention 48. Okay, and same thing we can do it. As I mentioned, we'll be constructing a rectangular face. From there we are going to dark the things. Okay, okay, so now you can see, analyze this front view. Okay, front view. So we need to have a dimension here. You can show the dimension which we have constructed a rectangular face here. Dimension of 104 here. We can mention that. Okay, 104, and this is we have 48 mm. Okay, height. Okay, so now you analyze the diagram. So in the diagram you can see the L type shape component we should get, and it is having a height of say 16, and from there it is having a dimension of say 24. So we can mark here 24, and then 16, like that we can do. So first I will be doing 24, marking for 24 mm, and then vertically downward I will draw a line. So mark for 24, okay, then vertically just draw a straight line, okay, and then here from this end we should exactly cut it at a height of 16, okay. So here also I'll drawing one line horizontally, okay, okay, and then we need to extend by 16 mm as it is mentioned. It's like steps. Steps were there exactly at 16 mm height, okay. Can construct that. So you can see here we will erase this part. It is similar to L shape, okay. We will erase that. Now we should dark the faces which is exactly visible from the front view, okay. We should dark it. So these are the faces. This is how it is exactly look like in front view, okay, in the front view. So we should dark that, okay. Okay, now we need to construct can show the dimensions, okay. It is so showing the dimension is, so it is having dimension of 24, and this is having a dimension of 16, okay. All these three steps are having a dimension of 16. However it is there in the front view, we are showing the dimension, okay. So dimension of, okay, 16 we should mention, okay. So we will draw project the lines here. We will draw the projection lines downward to draw the top view, because we know that these things are occurring in collinear. Okay, now we see the top view, so which is looking from the top. So from the top view we are able to see, okay, we are able to see this one. I am going to shade it with the straight lines here, okay. This face it is visible from the top view. By looking from the top view we are able to see this one, okay. I'm just shading it with the straight line here, okay, and this face also visible from the top view, okay. Okay, this is what it is visible. You can see, so it is having a length of 104, and then it is having a width of 72. 100 by 72 we should construct a rectangle here. First I will construct that 100, and then I will take 72, okay. So 104 we already have it here. 104 already we have it here. So you can just draw a line, okay. So draw the lines straight so that we get the exact dimensions, okay. Make sure you draw the straight lines. So 104, draw one line, and then another the width we should have it here, that is 72. So we'll erase this, okay. Okay, so you can show the dimensions. So one side we know it is 104, and the other side we have it is 72. We show the dimensions here, okay. So it is having a dimension of 72. Now we can see, So we will take up that. Okay, you can see it is like L shape we should get. Okay, first I will construct that L shape. You can see both the sides are having a space of exactly 24. So we will mark that first. Okay, 24 exactly 24 you can mark it. Okay, here also you can mark for 24. Okay, then draw lines here. So where they are intersecting, we get the L shape here. Okay. Okay, the L shape is done. Okay. Now you can see each of these rectangular faces having the dimension of again 24. So we can mention it. So it is 24. Okay. So this completes the top view. So we should dark it. Okay. Now we can mention dimensions here. So each of these top face having dimension of 24. Now we have to draw the side view. You can see like side view we should construct. Okay. So you can see this is what I will be shading that with the help of dots, the side view. Okay, that we will get a clear understanding of it, how to do that. Okay. So you can see adjacent to the front view we have the side view. Okay, I'll be drawing the projection lines here. Okay. Okay, in order to connect the side view with the top view, we should construct the 45-degree angle line. So this concept you all know it. To connecting the top view with respect to side view, we should construct the 45-degree angle line at the intersection of x5 and x1 y1. I'll be placing the protractor and marking for angle 45 degree. Now draw an angle line passing through this 45 degree. Draw a straight line. Okay, so this having an angle of 45 degree. Okay, now project the lines from top view till it touches the 45 degree angle. Okay, you can see in this problem there is a cube given. Dimension 40 is resting on HP with its base on HP such that one of its vertical face inclined at 30 degree to VP. That means we have to draw 30 degree. Then we have to place the square of dimension 40 on it. It is cut by a section plane perpendicular to VP inclined to HP at an angle of 45 degree. And it is passing exactly at the midpoint. You can see if the length it is 40, so we have to take 20. Then midpoint we have to draw 45 degree section plane here. And we need to draw the development of the lower lateral surface of the cube. So first we will be constructing an XY line. So here XY line you can take the thickness, either you can take 0.25 or 0.13, no problem. Then you can mention XY line VP HP because it is in first quadrant. Okay, you can mention that. Write XY and VP HP because this is in first quadrant. So in the development also we are using the first quadrant only. Now you draw an angle line. So here you should draw an angle line for 30 degree. So 30 degree means below the XY line you should give an angle of minus 150. Okay, 150 if you give, the angle you get it here 30 degree. You can measure the angle by using angle between command. Okay, so you will get the angle 30 degree. Now you have to take the square of dimension 40, and then we have to place with respect to that vertical edge. So you can give the width and height same, that is like using rectangle by center command, width 40 and height also 40. The angle you can give, that is 45 degree, so that it is easy for us. So when we place it on this 30-degree angle point, then we select this and go to move command and select the end point here, and then place it on this angle line. Okay, and then go to rotate, and then again you select this whole thing, because this entire thing you have to place it. So select the again end point from one end to another end, and then place it on the angle line. Okay, now after this, so we can draw the front view of it. So front view also having 40 mm dimension, because it is a prism. So we can write the naming for it, A, B, C, D. Only top face notations we can write. Okay, we're not writing all the face here. We can show the dimension here. It is 40 mm. Now we can project the line. From the end points. Okay. Straight projection lines you need to draw. Okay, you can zoom in and check it. Sometimes you are unable to do it. You can zoom in and you can do it. Okay, now you can see the height also, it is 40 mm. So we will be constructing for height of 40. Mention it. Okay, you need to draw exactly for 40 mm here. Then you can join. Okay, show the dimension. Can give the namings here, that is A, B, C, D, the vertical edges. Okay, now you can see here we have to draw an axis. So for that I'll be drawing the thin lines here, that is diagonal lines, to find out the center. Okay, and then I will draw an axis in the front view also. So I will draw thin line here because it is a prism. So cube is one of the prisms. So remember it, the inside lines we are drawing, it should be thin lines. Okay, it should be thin lines. You can mention it as O, and then you project it upward. Okay, and then from there you can you can draw a axis line here. Okay, okay, now exactly at the midpoint I'll be splitting this axis line so that we'll get the midpoint of the axis, because we have to draw an angle line exactly at the middle point of it. So we need to split it exactly at the half here. Use the split command, click on the axis and click on the midpoint. So it will get split into two halves. You can show the dimension for the lower part, so it will be exactly 20 mm. Okay, now you take a line, section plane, we have to draw an angle line for an angle of 45 degree here. Okay, you can give the angle 45 degree, enter, then you just draw a straight line. So we need to draw an angle line. Now using extend to next command, we can extend the same section plane downward also. Okay, so it is extended. Now I can show the angle. You can see that we have done. Now I'll be darkening the retained cut portion. Remaining cut portion we should make it dark. Okay, the upper part of it I'll be making it as a thin. Okay, you can see wherever the section plane has been cutted, from there I'll be drawing a projection line downward. Okay, projection line downward I'll be drawing it. From there, wherever the section plane we are having it, we are not going to draw. Where we don't have the vertical line projecting downward, in those cases I am drawing a straight line here. Okay, vertically downward. Okay, now the upper cut part will make it as thin line. Okay, lower part we should make it as a thick line. Okay, so you can again split if it is not splitted properly, you can split it and make that upper part, because we need to draw the development of the lower portion, so we should make sure that lower part should be in dark. Okay, now you can give the numericals number where we have cutted the section plane. Okay, this is where actually cutting started, so I'll mentioning this as 1, and it is occurring in between the vertical edges of A and B, so this is 1, and I'll mention this is 2, so the point number 2, it is exactly occurring at the end B, and then point number 3, so point number 3 we are getting exactly in between B and C, that is your point number 3. If we have drawn in a straight line projecting downward, you can see the point number 3 we are getting in between B and C. Okay, and that is our point number 5, so you can mention it. So this is 3, and this is 4, and this is 5. Okay, so 5 we are getting exactly on the vertical edge D here. Now we have to draw the development of this. You can see this, and this is exactly 1. Now we can see in this top view I am going to measure this length. In order to measure it, before that I am going to split it to the exact length, so that we can able to measure it, and the same length we can cut it in the development part. Okay, using smart dimensions you can able to measure the dimension of it. Measure exactly the length which we have cut it. You can see in both the cases we are getting exactly 8.45 and 14.64. Okay, so now we draw the development of this. So we are drawing a parallel line, a thin line here. Okay, a straight line. We'll draw a vertical line here. Now using offset command, I'll be taking 4 faces here at a distance of 40. Okay, from that vertical edge I'll be considering a distance of 40, enter. So the wrong side I have considered. You need to consider on the right side. Okay, 40, enter, click OK, and then you get the 4 faces here. Now we can mention the naming for it. It is capital A, capital B, capital C, capital D, and capital A. And now we can see here we need to mention this wherever we cutted the section plane with the number, we should mention from A to 1 on the line AB, it is 14.64. So I'll be taking arc by center point from the A point. I'll be measuring the length of 14.64 and cutting the arc. So cutting the arc, this is your point number 1. Okay, now we can see point number 2, we're getting exactly on the vertical edge B here. So for that I'll be drawing a horizontal line, so till here B. So this is the point number 2. Okay, and now for the point C,